Hello, I'm DJ Ware and welcome to my channel. Today we're going to be talking about installation and configuration of GlusterFS for Linux. If you saw my first video, you probably remember that we talked about scale up with SANs versus scale out with the clustered file systems like Ceph and Gluster and Lustre. So today we're going to take a look at one of those, and that is Gluster. So with that, let's take a look at the environment. So the environment that I'm going to set up today is on Ubuntu, and I'm going to be using Oracle's VirtualBox in order to create the necessary number of servers that we're going to need to do that. So I've got I'm going to use Vagrant to control that, because Vagrant makes it a lot easier to repeat success, if you will, and also to make sure that I'm using the same kinds of commands and libraries over and over again on each of the servers. So it allows me to give some consistency, and it gives me an environment that I can change easily without impacting my existing development environment on the bare metal machine. So I've got a Vagrant file, and this is a Ruby file that controls the actual setup and installation of, or provisioning, if you prefer, provisioning of the environment. So I'm starting out here with, I'm creating 3 files. These are the VDI files that will form the storage pool or the storage brick for Gluster. And so I have to define those ahead of time, since the default Vagrant install with Bento Ubuntu 18.04 only installs one disk drive for the operating system. It doesn't provide any additional ones for any additional software. So I'm having to configure that myself. So I got Vagrant. We're going to use the type 2. And I'm going to, as I said, pull the Bento Ubuntu 18.04, and I'm using 18.04 because it is a long-term service release, and I don't have to worry about the frequency of updates creating an issue where something might go haywire later on down the road. So, if in an enterprise environment, you spend a lot of time qualifying the environment, making sure that you've hardened it sufficiently for the exploits that you know about at the time. And so once you've done that, you lock the environment down, and you only apply security updates to it as needed. You don't update packages just because the version numbers change. And in fact, if you change a Unix kernel, that could cause a complete requalification of the environment. So that's the reason for using LTS. In the definition, we're going to define the first VM as Gluster1, and I'm going to just keep it consistent. The host name that's going to record down here will be Gluster1 as well. And I'm going to create there will be 2 networks. The Vagrant file system, or excuse me, the Vagrant provisioning system creates a default NAT environment already. And so this additional VM network is a private or host-only network that I'm giving a static IP address of 10.10.1.10 to that. And then we're defining the provider, in this case VirtualBox. Now Vagrant does work with Docker, it works with Hyper-V, works with VMware, and also Xen. There's a number of others that it works with as well. So you can use this to provision into a number of environments, but these commands are unique to VirtualBox. So these commands would be changed if you ported this over to Xen or over to VMware or Hyper-V. Those would change because you would need to have something set up specific for those systems, and you'd have to check your documentation for how you're customizing your particular provider. So the name of the host will be Gluster1. That'll be the internal name, and we're going to turn off the GUI because this is going to run headless. I could have put a check for the file first, but it's just as easy to comment it out after the first run. So you only need to run this one time, and that is to actually create the VDI file that we declared up here. And I've declared this one as a 20 gig file. And this one you have to do every time because this is a storage attach, which is actually taking this VDI file that you created and attaching it to the running VM. I'm also declaring 2 CPUs for this particular VM and then allocating 2 gig of memory to that. And then I repeat it for Gluster 2, except change the private IP address, and we're using file 2 instead of file 1. Otherwise the same. Gluster 3, same deal, change the IP address, change the file name that we're going to be using to attach. And the reason for the 3 is you don't want to use these same files that make up your bricks, and that's because you don't want multiple servers overwriting into the same physical disk. Otherwise, you will definitely run into problems with Gluster. It will get lost. It won't know what you were trying to accomplish. Anyway, then we'll define a client machine, and I don't need to declare any storage attachment for that. I just need to give it a unique IP address, and I've given it the same amount of memory. So right now my environment is down. So I thought, okay, I'll go ahead and bring this up. And we do that with a Vagrant up command. I'm going to leave some information in the description of this video where you can find some really good tutorials on Vagrant if you're interested in using it yourself. I'm not planning on covering that today. This is just more for my benefit to make things easier. And it's going through the provisioning steps to see if the VirtualBox has this environment set up already. And if so, it's going ahead and doing whatever customization work it needs to complete to initiate it getting running. And you'll notice it is starting to convert these into a running box, and it's moving on now to the second one that's now up and running. And it'll just go down through it in line and fire all those up. If these were missing, it would go ahead and create these environments inside of VirtualBox for you. The other thing I'd mention about Vagrant while we're waiting on this to come up is that Vagrant permits you to create an environment which is repeatable. That is, I can control, have a set of libraries, a set of applications, a set of packages that I need to support my development that I'm working on, and then I can share that with other people without running into that proverbial, well, it works on my machine, and I don't know why it's not working on yours, and because you're essentially giving them the exact same environment that you used to create the system that you're trying to let them either add on to or make changes to, or just evaluate that you did something that is working. So, I mean, that's what Vagrant is really good at. And then, as I mentioned earlier, then once you're done with it, you can destroy it without losing your existing environment. So, okay, so we've gotten our system up here. So the next thing to do is to go ahead and sign into Gluster 1, which is our first machine here. And I'm using the SSH command to do that, and it goes ahead and connects me. And so let's go to I'm gonna go ahead and we'll go over to get our setup instructions, and to do that we need to go to the Gluster repository or the Gluster homepage. So let's go to the start page here for it. This is for the open source community. If you're using Red Hat's version of it, and there is a slight difference with the Red Hat one that is included in their commercial product, which has a GUI in order to do that. So let's look at the install instructions for this. And so we'll come down here. As you can see, you can set it up in a virtual machine. There's a setup for physical servers, one's for AWS, and we're just going to go right here to the install instructions. And you'll see that there are specific entries for Debian, there's specific entries for Ubuntu, Red Hat, Fedora, and Arch. So we'll start here. You don't need to do this one for Ubuntu because I mean, to be honest, I've been using Gluster for about 3 or 4 years now, and I have never seen this yet where I've ever had to install that. So, but your mileage may vary, but if you do need to do that, there it is. you might be running an older version. So the first thing we want to do is we want to create our PPAs, to create the links to the PPA. And I don't want that 3.8, that's too old. So I'm going to start with 6. Now, I have used latest before, and that's kind of nice to be able to do, but I have run into issues with that in the past, so I don't do that anymore. I just stay within the major release, and then I watch for releases of 7 and 8 and 9 and so forth, and then I'll go read the instructions to see what the migration impact is to move from the current version I'm on to the latest one that's out there. So we'll go ahead and we'll do this, and I'm not actually going to do this because I already have it installed, but it would create the APT source list for you, and then you can do your APT update so that you refresh your APT directories and bring in the latest. Oh, I see we have an upgrade. So I'll go ahead and let's see what that is. See whether I want to do that or not. And it's for ELF. Okay. I'm going to skip that for now, and I would then do an install GlusterFS server. And again, I've already done this, but if on your system, it would go through and it would install the GlusterFS support, the common, and also the client. You can run the client on the server as well if you want to, if you have the resources free to be able to do that. So I've installed the software, and so the next thing I need to do is go over, and I'm not running a DNS, so I need to create a manual hard-coded entries for my servers so that each one of the servers knows where the others are. And so I've associated my IP addresses with the appropriate names. And I need to do that on all 4 of my VMs. Once I've done that, I would then go into Gluster, which is well, let's just see if we've got it installed successfully first. If this comes back with a version number, you're good. You're good to go. You're all set. So I can just bring it up, and the first thing you want to do is to associate the machines into a peer group or a pool if you prefer it, using the vernacular of Gluster. So I would then do a peer probe, and I would not include the one I'm on because it already knows that this is going to be included automatically. So I would do a peer probe on Gluster 2. It's already in the list, so there's nothing to be done there. I would do another one on Gluster 3. And then I could do a peer status to see what my other peers are that are connected. And then if I want to see the pool list, I can do that as well. And then it'll show me the unique identifier as well as the host name and the state. So I'm all good to go as far as the systems are concerned. They are communicating at least in a cursory level. So I will go to, I'm going to go to my last one as if I had finished up my last thing to do here. And what I'm going to do is I have a file out here called create rep. I'm going to copy that to, and I'll go ahead and, oops. By the way, if I make mistakes, I just leave them because I make mistakes just like everybody else. All right, so let's take a look at this for a minute. So there's my Gluster command that we were using earlier to do the peer and the status. And this is the first thing we're going to do is we're going to declare this as a volume command. We're going to perform a create operation, and this is the name of our volume. And then that volume is going to have 3 replicas. It's going to use the transport protocol of TCP/IP, And the first brick declaration is Gluster1, and then there's the directory SRV brick and rep2 and Gluster2 and so forth and so on. And one thing I just realized that I did not talk about, which we'll get to in a second, is the mounting of the file system. So I'll show you that in a second. Once that command is executed, it has if the rep2 is not already there, that'll go ahead and create the brick and make it ready for being used. So the next command is, after that, is once the brick is created, you would then start the services on it, so that the replication and the tracking and other metadata and all that would be copied across. So I'm going to change this to rep3 because I already have a rep2 out there. But one of the things I did not show you was I have the drive that I created, and this is an XFS. We can do this. We can do a sudo block ID, and then you can see that the STD is mounted as a type XFS, and there's my UUID for it. So XFS is important because XFS contains the metadata necessary for Gluster to be able to record where the files are located within the volume itself. So one of the things that you need to do is to make that brick directory. You can call that whatever you want, but that brick directory is the first directory under the XFS file system that has the XFS metadata contained within it that allows Gluster the extra items that it can use to locate that file. You can use ext4 as well, although it's a little bit more work for Gluster to do to find the file, because ext4 doesn't have quite as much richness. It isn't quite as rich in the metadata. And you can also use ZFS, which does have a fairly rich metadata for it. So that's another option that you can use. LVM is also possible to use as well if you want. And in fact, some of the releases of Gluster, they did recommend that at one time, and the performance was better. But I've noticed that late with 6, since they are starting to do some optimization, that it doesn't seem to make much difference whether it's LVM or XFS. So anyway, let's go ahead and we'll do that command in order to create my volume, and it's created it on all 3 of the Gluster servers, and I have a success. Now the type of volume that we're creating here is, if this comes over here, maybe it will. There we go. The choices that you have for these volumes are distributed, replicated, dispersed, and they all have different capabilities that they bring to the table, such as a distributed allows for scale storage when redundancy is either not important or is provided by hardware or software layers other than the system. So that means that you might use distributed if you're using ZFS for your file pool, because you already have replication as part of that if you've configured it. And then you have replicated where you want to be in extremely high availability and high reliability. This is also the poorest performing variant of the file systems. Distributed replica we'll talk about in a second. Let me bring up so you can see what it actually did. So the first thing we're going to do is a volume info, and this will list all of the volumes that are currently declared on the system. And I have 3. This is the first one, and it's a replicate. Second one, and then this is the one we just created, replica 3. And you'll notice that it is started. It doesn't have a snapshot against it yet, but you can snapshot Gluster volumes. This has got 1x3 bricks, and these are the brick names here across the servers. So if you wanted to create, for example, a distributed replica, you would need 9 bricks to do that, because you would need the number of bricks, number of servers, times the number of replicas in order to do the distributed. So you would need a total of 9 different bricks in order to accomplish that. And if you did that, then you would have a 20x3, so you'd have a 60 gigabyte file system. Let's see, what else can I tell you about it? Oh, let's look at status. This shows you the running state of the volumes, and it'll show you the bricks that are currently providing support for the file system itself, and that's these 3. It shows you the port it's running on, and you'll notice that that port is different for each of the bricks that are running on this group of servers. If I had used InfiniBand, the RDMA port would appear here, otherwise it's 0. The online status is good. It's a green for all 3 of those. And then there's the PID for the process ID of the system that's controlling the brick itself. And then you'll notice that it has these self-heal daemons on the local host, which is Gluster 3, the one I'm on, as well as Gluster 2 and 1. And these come into play if you're needing to rebuild one of the bricks because of a drive failure, or perhaps you had some other problem with it that destroyed that copy of or that brick itself. So maybe it's a channel problem, something like that. But what happens is the other hosts take on the responsibility for that file because they have a copy of that file available to them, and they will then participate if and when a new hard drive comes in on the server that's down, and they'll automatically start a self-heal process once that drive has been added back into the mix. And so it will then basically self-heal and rebuild the other drive that was there and return the system back to full performance. So we've done this. The next step would be we need to go to the client, and we're going to have a same kind of thing. We'll install the Gluster file system client software. And of course that's already done. This allows you to create the mount points that you need to mount that directory. So let's make sure that we don't currently have anything mounted, and we don't. So we'll do a sudo mount XFS, GlusterFS. And if you hadn't installed it, you would get an error right here when you tried to install this. So I'm going to put this on the mount directory, and it doesn't matter which one you pick. I'm going to pick Gluster 3 as the, except it does matter if you misspell it. And we want rep 3 to be the installation. So this is actually backwards here. Let's put it this way. Okay. And then we'll see that it is indeed mounted. Now, one of the things you'll notice is that mount is owned by root. So I need, and Gluster does understand POSIX access control, so we can do we'll set the owner to Vagrant. Okay, so, and then the next thing we will need to do is see if we can actually, you'll notice the brick directory isn't there because it's mounted below that. So let's see, this is this file to, and then I can retrieve that file from the Gluster servers. That's not really a very good test, so let's go ahead and do a show. We'll do a file, we'll do a sequential, and we'll do a 500 megabyte file. I've got some larger ones. I guess we could do one of the larger ones. Let's do one of the larger ones. Let's do one of the 2 gigabyte files. So this is still considered a small file for Gluster because they consider large files to be 11 gig and more and higher. So this is still considered very small. But we'll get some idea of how long. Now, right now it's laying out the file. So it's just writing it, and writing is going to be a little slower because it's got to write to all 3 of the systems first. So we're getting, looks like about 396 megabytes per second, about 198 IOPS on just recorded with the read. And of course, that makes IOPS kind of meaningless because you really should be measuring both read and write. So performance there wasn't too bad with that one. Let's see, do I have I think I have a BW. No, maybe not. Let's see. Oh, it's the other way around. Okay. I thought I had one that was right, so let's go ahead and do that. And of course, this will be a lot. This will not be very fast because it is, in order for the write to complete, all 3 replicas have to be finished writing. And so, yeah, and so it's gonna basically be sequential speed, a single speed across here. You're not going to get any gains from the reads in doing this. So we're about 140 megabytes per second. Not spectacular, not great. I wouldn't want to write home about that, but at least it's working. And we'll see. It looks like it's going to be pretty consistent, about 140, 142, somewhere in there. It's going to be about 140, I think. Yep, 141. And the IOPS looking about, at least for the write, look like they're about 70. And it gives you a percentile breakdown. So, by the way, these are run with buffer off. So this is going direct into the drive. So it's not taking advantage of any caching that might be going on inside of the operating system. That's kind of where what I wanted to show you today. One other thing, if you want more information about Gluster, this is a really good place to come. They have some really good write-ups on the different types of files, types of volumes that you might want to use in Gluster and when it is appropriate to do that. One thing that the Gluster folks have said over and over and over again, almost at every conference, is that get your use case together first. Make sure you're doing, if you're going to do large files, that you set up your system for large files. If you need high performance, make sure you're picking a volume that is supporting high performance. And don't just rush it into production. You might want to scale it up a little bit at a time. I know that CERN has been doing that as well with Ceph. And so you want to scale up, make sure that you're hitting your milestones as you go along, and you're validating that your choices for your use case was valid and good. And if you do that, you'll get a very high performance system and with great reliability. And so with that, I'm going to conclude it. If you have any questions, please leave them in the comments below. If you have comments, always welcome to hear those, good and bad. That's the way we improve. I want to thank you very much if you got this far for listening to the video today. Hope to see you again soon, and thanks again for being here. Bye for now.